In this video, I'm going to teach you how to go about equations of tangents and normal. So equations of tangent and normal, this is under calculus. Okay, this is under calculus, and such questions normally come in paper 2 of ECZ exam, which is syllabus D. We call it syllabus D. So now, just a simple explanation on the difference between tangent and normal. Okay, the tangent line and normal line to the curve. Okay, so this is the Cartesian plane or the X or Y plane. Okay, and this is the graph of the curve. This is the curve, all right, and its equation is this. Now, look at this. A tangent line is the line that touches a circle at a single point. Okay, at a single point. So this is a line like this. The blue one here is touching the circle at a single at a single point. That is a tangent line. Okay. Now the way we deal with a tangent line when it comes to solving equations is different from the way we deal with in fact the difference is there's a slight difference. Okay, I'll show you. The difference is in when finding gradient between the two, normal and tangent. So the line that is perpendicular to the line of tangent or to the curve here is called the equation or the normal line, and its equation, if you want to find the equation, the gradient will be m is equals to -1 over the dy dx, or the derivative of the function, which is this function. Nice. And then this one, you don't even have to include negative when they ask you to find the equation of a tangent. You just have to solve, guys, dy dx and solve for gradient. Okay, gradient where at the single point here. So for you to find the equation of any equation here, both either tangent or normal, the first thing they should give you a point. All right, so you need the equation itself, to a point. All right, which is they can give you x, sometimes in x, comma y. All right, now to explain this one further, let's look at 2022 paper 2 question 6b. All right, so they are saying find the equation of the normal. So find the equation of the normal. The key is normal here, is not tangent. Find the equation of the normal to the curve. So we are given the function, which is y is equals to x squared minus 3x minus 4 at the point. So at the point, the point is 2, -6. Guys, simple. This is simple. As long as we are given you the equation, the statement is either normal or whether it's normal or tangent, of which is normal. Number 2, the equation, which is this one. Then the point, which is this point here. So what you do is find the dy dx of this equation function. You derivate this function, find the derivative of that function, of which you are going to say, let's write the function y is equals to x squared minus 3x. Is it squared or cubed? Okay, it's squared. All right, minus 3x minus 4. All right, so what you do, you find the derivative. So we're going to say dy dx is equals to the coefficient here will be multiplied by the power, which will be just 2x. 2 minus 1 will be just x, minus there is a power here, negative positive 1, and invisible 1 times 3 will be just 3. Then the dy dx of a constant number is 0. Okay, now we have this. Now we're going to replace dy dx here. Always remember to replace dy dx with the gradient, which is m is equals to 2. Where there is x here, substitute the value of x here. This is x and this is y. We're going to say 2 minus 3. So gradient is equals to 2 times 2 is 4. 4 minus 3 is 1. Okay, 1 here. Now, since it's equation of the normal, don't forget here. So we're going to say negative 1 over the dy dx of everything here. Dy dx is same as the gradient, and the gradient we found is 1. So negative 1 over 1, which is 1 into negative 1, which is just negative 1. So you have the gradient of the normal, negative 1, and the point, which is 2, negative 6. Then the equation can be found easily. The formula for the finding equation of a line is y minus y1 is equals to mx minus x1. Then we substitute. Okay, we substitute. So okay, so this is the equation. So this is x1, this is y1, and this is the gradient, which is negative 1. So I'm going to say y minus y1 is negative 6. So I'm going to say negative 6 is equals to, gradient is negative, so we'll say negative 1, open bracket, x minus x1 is 2. Okay, like this. Then this will be just negative times negative will be y plus 6 is equals to negative 1 times x will be negative x. Negative 1 times negative 2 will be positive 2. Then this 6 will cross the equal sign, and it will be y is equals to negative x plus 2 minus 6. All right, solve the like terms here. I'm going to say therefore the equation of the normal will be y is equals to negative x 2 minus 6 is negative 4, and this is the answer. All right, the answer. Sometimes leave it as they leave it as a y. The x will cross the cosine, it becomes positive x is equals to negative 4, which is just the same. Okay, this is equation of the normal. All right, so if this one was equation of the tangent, look at this. If this one was equation of the tangent, we would have solved it the same way up to here, where we find the gradient here. But we will not go and substitute negative 1 over the gradient now. No, we're going to use the same gradient we found here, direct with the point which is here, direct. So tangent is easier. So whatever gradient you find here, that is the tangent. Okay, but for normal, always the gradient you find here, let's say the gradient you find 2. For normal, it will be negative 1. It will be m is equals to negative 1 over the gradient, which is what? Which is 2. Okay, well, which is 2. There, then what? Yeah. So this one will be considered as this one is considered as tangent. Then this one is normal. Okay, it is as simple as this. Thank you so much.